Hey, welcome to the Explainer. Today we are jumping into the world of 3D shapes. We're going to break down the fundamentals of solid geometry, moving beyond those flat drawings on a page and into the shapes that actually make up our world. So let's dive right in with a question. How in the world does a flat shape become a 3D object? To get to the bottom of that, we have to take a leap right out of the flat world of 2 dimensions and into the space-filled world of 3. All right, before we can really start building anything, we need to know the parts. To get a handle on 3D shapes, we've got to start with their most basic building blocks. First up, we've got the face. Now, on any solid shape, a face is just a flat surface. Think about a simple cube. Each one of its 6 square sides, that's a face. It's the part you can lay your hand on. Okay, next up is the edge. An edge is that line segment you see where 2 faces meet up. Sticking with our cube, it's got 12 of these edges. They kind of form the skeleton of the whole shape. And finally, the vertex. A vertex is, well, it's just a corner. It's the point where 3 or more of those edges all come together. Our cube has 8 of them. So there you go. Faces, edges, and vertices. That's the DNA of these shapes. So now that we have the building blocks down, let's meet the main families of solids. And trust me, you'll see these guys pretty much everywhere. Okay, so most of the common solids you're going to run into belong to one of these 4 families. The real difference between them boils down to just 2 things. What shape is their base? Is it a polygon or a circle? And do the sides go up to a single point, or do they go up to a matching base on top? The good news is, naming these shapes is actually super straightforward. The name literally comes from the shape of its base. So a prism with a triangular base, it's a triangular prism. A pyramid with a pentagon for a base, you got it, a pentagonal pyramid. The name tells you exactly what you're looking at. So what's the big difference here? Well, think of it like this. A prism has 2 identical parallel bases, kind of like the floor and the ceiling of a room. A pyramid, on the other hand, it's only got 1 base, and all its other faces rise up to meet at a single point, just like a tent. We've seen how these solids are put together. But what happens if we do the exact opposite? I mean, imagine taking a 3D shape and just carefully unfolding it, laying it out totally flat. That flat pattern you get, it's called a net. It's basically the 2D blueprint for a 3D object. You remember that cardboard box from the beginning? That flat piece of cardboard it started as? That is its net. Okay, so check this out. It's like a fun little puzzle. Looking at this net right here, we've got 1 square smack in the middle and 4 triangles, 1 attached to each side. Just take a second and try to picture it in your head. If you were to fold up those triangular flaps, what kind of shape would they make? Where would all their pointy tips meet? If you saw it in your mind's eye, you saw that square becoming the base, while the 4 triangles fold up to meet at 1 single point, creating a perfect square pyramid. All right, we just built solids up from flat nets. Now let's flip that idea on its head and see what happens when we deconstruct them by slicing right through the middle. This slice we're talking about is called a cross-section. It's like when you slice through an apple. That shape you see on the inside where you made the cut, that's its cross-section. It's like a 2D window into a 3D world. So, picture a cone like an ice cream cone. Now imagine making 1 clean cut, straight from the very tip all the way down to the base. What 2D shape do you think that slice is going to reveal? It's a triangle. Yeah, slicing a cone in exactly this way perfectly reveals a hidden 2-dimensional triangle that was just waiting inside its structure. Okay, let's try another one. This time, we've got a cylinder. Think of a can of soup. What happens if we slice it horizontally, perfectly parallel to the top and bottom lids? The result is a perfect circle, an identical copy of the cylinder's base. And this is a really powerful idea. The shape of the cross-section you get depends entirely on the angle of your slice. So let's apply this whole idea to a really fun, real-world example they talk about in the source material, a cube-shaped watermelon. Okay, this one should be the easy one. If you've got a cube, what's the most direct, no-fuss way to get a square slice out of it? Exactly. A cut that's parallel to any of the cube's 6 faces is going to give you a cross-section that is a perfect square. Simple as that. But now for the real challenge. How is it even possible to get a 6-sided shape, a hexagon, by slicing a 6-sided cube? And here's the secret sauce. By angling the cut just right so that it passes perfectly through the middle of 6 different edges, the chef reveals a hexagonal cross-section. That six-sided shape was literally hidden inside the cube the whole time.
And that really brings us to a final, pretty cool question. From folding up nets to slicing out cross-sections, we've seen that even the most basic shapes are holding on to some hidden complexity. It really makes you wonder what other surprising forms are just waiting to be discovered inside the objects we see every single day. Thanks for joining us.